Hello, we're going to talk about SHM and sinusoidal motion. So if you recall, we talked about the UCM and SHM relationship using this circle before. And so X, it's right here. So this is X. It's from the equilibrium position. So it's like that, okay, sorry. So this is equilibrium position. And this is the, the current position for SHM. So that's the displacement at this point from the equilibrium position. So that's x. X is equal to a, which is the radius here, times cosine theta, right? Or cosine theta is equal to x divided by a. So we rewrite that x is equal to a cosine theta from here, right? X is equal to a cosine theta. So theta, if we take a look at the kinematics, omega is equal to delta theta delta t. And delta theta is theta final minus theta initial. And delta t is tf minus ti. If we let theta I and ti initial angle and initial time to be 0, which we can set. So we can set it that way. So we set it to 0. So, and we just simplify the notation theta f to theta and tf to t. So then we have this. So basically, omega times t is equal to theta, or omega, yeah, so omega times t is equal to theta. So we're going to replace this theta by the omega t now, right, using this here, right, using omega is equal to theta divided by t, or theta is equal to omega t, right? So theta equal to omega t. So that's what we have. Okay, so you can see this says that the displacement in SHM is a cosine function of time, right? And then with omega in there, and omega is your angular velocity of UCM. Okay, so that's how they relate it. And if you plot this, it basically says that the displacement in SHM, it's oscillating like a cosine function with time. Okay, remember that. All right, so let's take a look at the velocity part, right? So now we know displacement, and we know this velocity is equal to displacement divided by delta t, right? So delta x delta t is v, which is from kinematics, 运动学. So delta x, right? So we put x is here. So delta x is delta a of this guy, right? So delta a and cosine omega t. So delta a cosine omega t. So that's delta x and delta t. So a is constant. We move it out, right? And then delta cosine omega t divided by delta t. So that's from pre-calculus. This relationship, it's there, okay? So if you took delta omega t, delta cosine omega t divided by delta t, that is minus omega. So you take the omega out and you put a minus sign there. And then this delta cosine omega t delta t will be minus omega times sine omega t. So basically this relationship is there. So now we look at this here, a comes out, delta cosine omega t delta t, which is equal to this one here. We're going to put this one here into here. So then the minus sign is going to be here, and a is coming out. And then omega sine omega t is still omega sine omega t. So a omega, which is r omega, right? Remember, we have v max, which is this one here, right? It's equal to r times omega, right? But r here is a, so it's a omega. So v max, which is the linear speed in UCM, or the v max is also the max velocity in SHM, right? So right here at the equilibrium position, and this is your equilibrium position right there. Okay? So right here, a omega, it's basically v max, which is the maximum velocity in SHM. So then you have minus v max times sine omega t. So you can see v in, so this v is the v here, right? So this one here has the v going this way right now, which is the v of this one here at this position, right? So this is v is a function of sine. So again, we are saying the following. We're saying velocity, right, in SHM, right, is a sine function of time. So just like here, the displacement is in SHM is a cosine function of time. And this says the velocity is a sine function of time. And sine and cosine are the same. There's a little phase difference, right? There's just only the phase difference. So they essentially are the same. It's just a little phase difference. So now we have V is equal to minus V max sine omega t. So you can plot this out, right? So this X looks like this now. So A cosine omega t, so we right there, right? This is X and this is T, right? So this is how the displacement change with time in the SHM. So it's a cosine function like that. And the velocity inside the SHM looks like this. Velocity, right? And it's minus V max. So then it's starting from this here, okay? And then it's going to go downward, right? Downward like that, okay? Downward like that. Yeah, right there, okay? Like that. And it's going to come out like that, right? Yeah, right there, right? And then it's going to go back down again, right? So it's like that. So this is the minus Vx, Vmax. So that's the Vmax right there. Okay, Vmax, but it's the opposite, right? So because the minus sign, so it's going down first and then go up. So this is a sine function with the Vmax as the maximum value of the peak here. Okay, so you can see both x, v, and also the acceleration too. If you go and plot acceleration with time, which will be your homework, you will do it yourself. That a versus time is also sinusoidal. Okay, so we're going to stop there. That's talking about SHM and the relationship with the sinusoidal motion, which is quite interesting. Okay, all right. If you're interested, keep watching. Bye bye now.